This is GATE 2014 Set 2 Electrical question number 8. A parallel plate capacitor consisting two dielectric materials is shown in the figure. The middle dielectric slab is placed symmetrically with respect to the plates. Now the potential difference between one of the plates and the nearest surface of the dielectric is twofold. Then the ratio of epsilon 1 is to epsilon 2 is there. The four options are given. So as you see, due to the placing of the two dielectric materials, the three capacitances have been formed. Right, coming to the useful data.
Now you see two different dielectric materials are there. These three segments, two dielectric materials are there. So this one is epsilon 1, this one is also epsilon 1, same material, and here you have epsilon 2 material, and these are the conducting plates, metal plates. These are the metal plates. So effective capacitance of this area is C1, this area is C2, and this section is C3. Now the effective capacitance is series combination of C1, C3 and C2. Now you see, if the charge on this is plus Q, right, it's showing here, let's say this is a metal plate, the charge on this is plus Q, and this is another metal plate. So you apply Gauss law now. Take a closed surface around this enclosure, that is, the electric field inside this metal should be 0. Now since the distance between the capacitor plates D is much small than A, all these are infinite charged plates. So due to infinite charged plate, you know the electric field is sigma by 2 epsilon naught, where sigma is the surface charge density. Now for this plate here is a sigma by 2 epsilon naught, right? So this point is absolutely near or inside the surface. So this is pushing it, someone should pull it. So here same sigma by 2 epsilon naught should come, or in other words, due to Gauss law, the net charge enclosure should be 0. So here minus Q should come. Similarly, another plate you put, this will also have plus Q, because this is minus Q, so this enclosure you take, there should be plus Q. So for such configuration of series connected capacitors, charge on all capacitors, that is the magnitude of charge, mod charge, are same with alternating plus and minus signs, right? So this is plus and this is 0, because you have seen in the problem it is given this is grounded. So this is grounded. So this is solely due to the fact of Gauss law that electric field inside a conducting body or a metal plate that is conducting is equal to 0 always. So this is the basic philosophy behind such thing. Another thing you need to know, series combination of C1, C2 up to Cn will be equal to 1 by C1 plus 1 by C2 up to 1 by Cn. So this will be needed in order to solve this question.
C1 is epsilon 1. So and also that this is d by 2. So drawing it once again, this is d by 2, this is d, so these two distance sum is d by 2, so half of that d by 4 d by 4. So this is epsilon 1, this is epsilon 2, this is epsilon 1, and all these are a. So c1 is a epsilon 1 by d1, sorry d by 4, c2 is a epsilon 2 by d by 2, c3 is a epsilon 1 by d by 4. So these are equal. Now what is being asked in the question is, now given that potential difference between one of the plates and the nearest surface of the dielectric, let's say this plate, because these and these are equivalent, symmetrical, right? So let's check one. So for capacitor 1, voltage across capacitor 1 is Q equal to CV. So C1 into V1 equal to Q is the charge. Again, C equivalent into voltage difference between the plate, this one and this one, is also Q. So 10 volt. So 10 into C equivalent, which is 1 by 1 by C1 plus 1 by C2 plus 1 by C3 equal to C1 VC1, which is equal to C1 into VC1. Now VC1 is 2 volt given in the question, you see, this is 2 volts. So we can say this is 5. So C1 into 1 by C1 plus 1 by C2 plus 1 by C3 equal to 5. Now 1 plus C1 by C2 plus C1 and C3 are also same, so 1 equal to 5. A epsilon 1 by d by 4, and this is C2, A epsilon 2 divided by d by 2, this is coming out to be 3, implies epsilon 1 into 4 by d divided by A gets cancelled, right? And d you can also cancel, into 4, that's it, divided by 2 epsilon 2, right, equal to 3. So epsilon 1 by epsilon 2, this 2 is equal to 3 by 2. So 3:2 is the ratio of epsilon 1 and epsilon 2. Three by 2 is epsilon 1 by epsilon 2. This is the answer, 3 by 2. So option C is correct. Thank you.